This conference will now be
A very
recorded.
good time to everyone. I would like to welcome you all to this International Robotics Training Program organized by Encino Research and Development Private Limited. I'm Ashok Kumar, and I would be your trainer for this 2 days International Robotics Training Program. So, as we already know, it's being already shared that what content we are going to cover in this 2 days training. Anyways, I'll update it again. We are obviously, when talking about the robotics, so we'll be discussing about the basics of robots, including a few part of ROS, which is called Robot Operating System. Not a real operating system, but a virtual operating system, which we will be using for how robot works, how industry grade robots actually work. So that would be the achievement if we complete by the 2 days, right? And but like whenever we have to start with the robotics, obviously first we need to understand the basic concepts, right? Few days ago, we had one more session that was based on PLC. It was also absolutely free for international students as well. And after that, it took too much time to decide the dates because I was too much occupied with other training programs. And finally, we are here on 25th April 2026 for this robotics program. As I promised in the last session that we'll be doing continuously a few programs for free of cost so that the participants from different countries can also get the knowledge of the topics. Also, when we did the last session, it was a lag that we did the last session on YouTube Live, and that time uh, participants were not having the option to discuss their doubts directly with me because YouTube Live does not allows to interact directly with the host. But as discussed in the last session, we had few free Zoom sessions as well where I directly connected with the participants. They asked me their queries and I was able to solve them at that time. Now is the time when we are meeting in live session. It's completely live. It's not pre-recorded. Okay. And you'll be having time slot where we will be discussing about too many doubts, right? But one thing practically I would like to say here, although you all have joined, so I should not say to you guys because you are responsible, registered, joined the group, and today you are here in the session. But as I can see in the list of the forms, there were almost 1,000 and 1,300 students who registered for this program. Out of those, approximately 300 joined the groups and approximately 90 participants are here who are joining the WhatsApp group. So, I mean, why I'm saying this because when you register for any program, you must be attentive because when we have registered, we should know that we have these dates. So we should save the dates on calendar because it shows us the professionalism as well. Although I should not say this thing with you guys because you are already here, you are already joining the live session. Anyways, leave it behind. Now, let me tell you the agenda. First, we are going to start with the theory part somewhere around 10 to 15 minutes, right? I've already shared the software list, which you must have downloaded. I'll tell you the steps to install as well, right? If you have your own PCs, laptops, you can install. Those who don't have their PCs, laptops, and joining through only mobile phone, and if they also want to practice, I'll tell you the options for that as well, right? But that those are online platforms. I'll tell you about those things as well, no problem. But that is the later part. First, we need to discuss about the theory, right? Currently, I'm not going to take any doubts, even not in the chat box as well, because as you know, last session was the YouTube live where I was continuously watching the chat room because the session was pre-recorded and running in the live session. But now is the time when we are doing it completely live. So I'm already engaged, speaking, interacting with you. So currently I can't take any doubts, obviously, when we have not started anything. So I guess no one should be having the doubts for now. But yeah, later, after some time, let's say After 40 to 45 minutes, we'll have a quick doubt session where you can speak, turning on your mics, and you can speak whatever questions you have. Right. So for now, I'm going to share my screen and let's begin it. Is my screen shared with you? So please react on that also. Okay, that's good. Give me a moment. Yeah. Okay. So as I already mentioned that we are going to discuss about the robotics part. Also, we'll be discussing about the part of embedded systems and ROS because whenever we discuss about robotics, it comes along with the embedded system. And the next level which we have to achieve is ROS, that is robot operating system, right? So robotics is obviously what? The study of robots. Robotics is nothing but the study of robots. And robots are obviously the clone of human, we can say. Although robots are not always in the form of a human, it can be anything, it can be any machine which can behave or which can work like a robot. So, always we cannot say that robots are the clone of human. But why I'm saying this line? Because, like, we have sensors in our body, like, we have actuators, actuators mean the hands, legs, to generate the output to perform the activity. The same ways we have in the machines, in the robots also. That's why I'm saying the clone of robot, the clone of human. Although we have different categories, like we can say a machine robot, we can say a vehicle robot, or we can say a human robot. So when we talk about a human robot, it is called humanoid. And when we say machine, it's simply a machine robot. And when we say vehicles like cars and bikes, so those are called vehicular robots. Vehicular robots. So we have three different special categories for the robots. And the main category is obviously vehicular robot and the humanoid robot. Right now, when we are doing this training, you have joined this. I'm working as a host. That time also, we are using the robots. The laptops which we are using is also the category of robots. Maybe we are sitting in a room which must be having a AC. That is also a category of a robot. Maybe you have a smart fan is also a category of a robot, right? So before we go ahead to understand the facts about the robot, first we need to understand what is actually a robot and what is actually not a robot, right? So obviously, robot sounds interesting and it comes from the word robota, and a very important, a very important part of the robot is that it is a kind of machine which can take own decisions. So if I ask you a fan and a smart fan, they both are the machines, right? A fan and a smart fan. They both are the machines. But smart fan is category of robot, whereas the fan is not a category of robot. So how to understand what is actually a robot or what is not actually a robot? For that, first we need to understand the facts about the machine, the facts about the process, the facts about the automation. So I'll start with the control. There are two type of controls. The one is manual control and the second one is automatic control. The one is manual control and the second one is automatic control. Whenever we want to control the process with human efforts, it is simply a manual controlling process. And whenever we want not to put so much of human efforts, and it should done automatically is called automatic control. So that's how I'm dividing this control in two different processes. Now we'll be discussing about the automatic control process. Now automatic control process is what? As soon as you enter your room, the lights turned on automatically, the fans turned on automatically, the door opens automatically. When you goes off, lights goes off, fans goes off, close door closed automatically. So kind of process. Now if I relate this process to industry, where we can see a lot of things. A lot of things mean manufacturing, packaging, production. Too many things are dependent, obviously not on human. Those processes are working automatically, and that is also that is also a category of automatic control. Now, to perform this automatic control, what we need, obviously, machines, right? Obviously, what? Machines. But if a machine, let's say, now I'm talking about a fan. So, fan is normally a machine. It is not a robot. How? Because I need to turn on and turn off the fan, right? I cannot control this automatically for now. Let's take an example. So I'll go to the switch to turn on. I'll go to the switch to turn on. Although that's a secondary part, we can use uh, RF, we can use the remote, or we can use the Android application to turn it on or to turn it off, right? But those are also a process of control, and I'm doing it manually. It's not being done automatically. Automatically is what? As soon as I enter the room, fan senses and turned on, and after that also it should sense my body temperature and regulate the speed accordingly. If I'm feeling so hot, the speed should be high. If I'm feeling cold, it should turn off. And if it's like a moderate temperature, the speed should be moderate. That time I can say the fan is taking its own decision and it's smart. And whenever we add the word smart with any machine, that is equals to a robot. So what is robot? What is not robot is very simple. Machine without smartness is simply a machine. But a machine with smartness, a machine with a brain is robot. So we can also say in other language, whenever we start programming the machine, it is equals to a robot. Now, it's not only about a vehicle robot or a humanoid robot. It is about all the robots, like a laptop, like a refrigerator, a washing machine, a AC, and all maximum appliances which we are using in domestic applications and working automatically is a category of smart machine, programmed machine, or a robot, right? So I guess now we all understood that what is a robot. Now, why we are dependent upon these things just to reduce the human efforts, just to reduce the manpower, just to improve the efficiency, to improve the production, to improve the quality. And all other facts are also there. That suppose if I ask you to fill a bottle, to fill a bottle, and almost 1,000 bottles in a day you have to fill, and regularly you have to do the same task for 30 days. Obviously, after maybe 1 day or 2 day, we'll get bored of. But if we assign the same task to a smart machine or a robot, they can do it again and again. So also it is mentioned in the slide I'm sharing, the very first line. Moreover, robots don't get bored of while doing same task again and again. They don't need sleep or rest, which means they never feel tired. They don't need any holidays. They don't even have any excuses. Like suppose maybe you are working, maybe you are a student, and when you are waking up early in the morning and you are not in the mood to go your office or school or your college, so you are deciding, let's leave it, I'm not going, and you are giving excuses to your concerned department that I'm not feeling well, I can't come. So we have too many excuses, right? But the machines don't have any excuses. If they have to work, they'll work tirelessly. 24 cross 7 cross 365, they can work. They don't have any excuse. They don't have any vacations. They don't even want any sleep or rest. So that is why we are dependent upon the robots. Now we need to understand the name of the very first robot. And this is the image which I am showing you here is the category of very first robot. And It was to deal with the pieces of hot metal, and it was named as Unimate. In 1961, this was designed, right? Now, when I was showing you the very first slide, robotics, obviously related to robot, we understood well now. Now, when I'm coming to the second part, embedded system, so robotics is somewhere connected to the embedded system. And in even the last session when we had with the PLCs, I told you that time embedded system is the combination of hardware as well as software. I do understand uh, participants are not common, obviously. They all participants are not here, so that's why I'm repeating the same kind of things again. So embedded system is the category of hardware as well as software. And the hardware part is basically a microcontroller, whereas the software part is your programming part, where we'll be do the programming. So using that program, we will control the hardware. Using that program, we will establish a process to being done automatically is a category of embedded system. But whenever we discuss about the microcontroller, the comparison we do with microprocessors as well. Whenever we discuss about the microcontrollers, micro mean very small and controller mean the device which controls. And on the other hand, we have microprocessor, again small processors to deal with multiple processing units. For example, your computer is the category of microprocessor where you can do multiple tasks simultaneously. So if I define you in one line, I'll say microcontroller is designed to solve one specific application, or it is designed to solve one dedicated application, whereas microprocessors are designed to solve multiple applications at a time, whereas microprocessors are designed to solve multiple applications at a time. Now, when we start comparing the size of microprocessors and microcontrollers, I can say the size of microprocessor is bigger as compared to controller, because all the external peripherals, for example, RAM, ROM, input output ports, memory, hard drives, for example, and the power supply. Each and everything is connected externally in the case of microprocessors. But on the other hand, when we are talking about the microcontrollers, maximum peripherals are inbuilt in one small IC, right? So in now in a line, I'll tell you microprocessor equals to CPU on a chip and microcontroller equals to computer on a chip. CPU on a chip and computer on a chip. But when we talk about the embedded system, there we not need to discuss too much about microprocessors. There we discuss about the microcontrollers only. Now, when we are talking about the robots, obviously it is a category of microcontroller. It is a category of embedded systems. But the line which I just said is from 2010 or 2012. Nowadays, when we are living in an era of 2026 and we are surrounded by almost AI, that time this line would be completely wrong, because the base of the robot is obviously same. It is microcontroller when we have to sense using the sensors, or when we have to uh, actuate the outputs, when we have to use the actuators. Obviously, it's a part of microcontroller. But nowadays, when we have to include the part of ML, when we have to include the part of AI, or when we have to include the part of DS, data science, obviously we need the microprocessor. So nowadays, the full package of your robot is not just a microcontroller, it is the combo of microcontroller as well as microprocessors. That is why nowadays, whenever we go to opt the robot, we need to identify a device which can work for both simultaneously. Now, if I name few controllers like 8051, like STM32, like AVR, like Jetson Nano, like Arduino, like uh, Microbit, so they have the categories with GPIUs. But when we discuss about connecting the ML, when we discuss about connecting the AI, obviously we have few restrictions, and that time we need to think about the processor task as well. So that time we go for maybe your laptops to operate the AI, maybe your Raspberry Pi to operate the AI, and other categories, Jetson Nano that we can do. And nowadays we have other controllers as well, very small controllers for that. They work as simultaneously for the processors also. But what I'm saying, if you have to build a robot and you are required to perform the AI operation as well. So, which means you need microprocessor as well as microcontroller, but it is also making your system very bulky one, a very bulky one. So, why not to use the ROS? Why not to use the ROS? Right now the time when we have to discuss about the ROS. ROS is what? ROS is robot operating system. Operating system we all have heard about. Currently, when I'm sharing my screen, you can see it's Windows 11. Also, you may have in Windows 10 in your PCs, Windows 11, Windows 8, Windows 7, XP, Vista, Mac OS. So OS mean operating system is a collection of multiple software and is a collection of multiple programs and is a collection of multiple instructions. A laptop where we have to work with, suppose, Word, PDF, Paint, Corel, or too many other softwares. Obviously, we need an environment where we can run these softwares, and that environment is obviously called OS, operating system. So now when I'm talking about the AI robots, you need to perform machine learning, you need to perform data science, you need to perform the set of libraries or too many other data set. So obviously you need operating system to operate these things. Now what I'm saying, when we have to work with all these kind of scenarios of AI and machine learning and data science and IoT, why to opt the OS like Windows 7, 8, 10 when we have own operating system of robot, which is called robot operating system. You must not have heard about any operating system related to robot earlier because the name which I'm using, ROS, robot operating system, is not a real operating system like your Windows 7, 8, 10 or XP Vista or your Mac OS. It's not actually a real operating system. ROS mean not real operating system. ROS mean robot operating system, and it's completely a virtual environment which we create on a microprocessor so that they can work smoothly for your AI algorithms, for your machine learning algorithms, and whenever we have to communicate with the brain of the robot, we can easily perform the task. So what actually it does, it reduced the memory size, it increased the speed, also it reduced the bugs and the lags in your decision making part of robot. That is actually the robot operating system. And that is my target to achieve by tomorrow so that when we end this session, we can say, yes, we have learned something from this, right? So I'll end up with the theory for now because I guess that is too much to discuss about the uh, robotics embedded system and ROS, which I just shared. Right now, I'm coming to the point which I have shared with you guys, and that is the software package. I've shared the link, right? Let me go back to the link again for you guys. So the link was encino.in/IoT software dot rar. So as soon as you click enter, it will start automatically, right? It is asking me to keep. So if I keep, it will start downloading. For now, in my PC, it is already downloaded. Obviously, I not need to do, so I'm canceling it, right? Now, going back to that folder where I have downloaded this. So if we see here, I have a package of IoT software, right? The package which I shared is a RAR file, a compressed file, which you need to extract. I hope you all know how to extract the package. Simply, whatever package I have shared, like this IoT software, if you have installed 7-zip or WinRAR, you simply need to right tap, show more options, and extract to IoT software. Or otherwise, you have inbuilt in Windows 11 extract all option, but generally it doesn't work every time. So I suggest you to download the WinRAR package or a 7-zip. 7-zip is completely free, open source. You can use that. And WinRAR is the best one, advisable, right? So simply right tap on this to extract. For example, I'll do this in front of you, right? And it will create a folder like this. So once the process is completed, this whole process is completed, all the files you'll be getting in this folder, IoT software, right? And once you open this, here you will see all the required softwares. Currently, it's not completely extracted. That's why all the packages are not there for now. Now we have all the packages, right? So here we have the Arduino IDE software, which you not actually need to install because it's a pre-installed version. You simply need to select what I have done till now. Let me tell you again. This is the software package, IoT software, right tab, show more options and extract. Once we extract, we'll get the folder like this. And in that folder, we have the folder of IoT workshop. There we have the folder of Arduino, right? So we are going to use the Arduino for this robotics for now, for the very first day. And let me also tell you one thing. We are not going to use the Arduino Uno controller. Okay. We'll be using one IC of this to make the circuits and to perform the operations of robotics. Directly, we will not be using the board of Arduino. I'll tell you when I'll come to that part. So the software which we'll be using is obviously Arduino IDE, Integrated Development Environment, and the current version is 2.2 something, which you can 2.3 something, which you can download from the official website of Arduino.cc. That is completely open source. But for now, you not need to download because I have already shared. Also, this is pre-installed version. You not even need to install this. Simply right tap on this. You'll get the option of show more options and then send to desktop, create shortcut, right? In few PCs, if you are using Windows 8, 7 or 10, on the right tab only, you will get the option of send to. If you are using Windows 11, then you will get the option same like mine. Okay, so that's just a change of interface because of the OS. In my case, when I'm using Windows 11, it is showing me the things accordingly. So I need to go to show more options, send to desktop, create shortcut. So as soon as you click on this, you'll be able to see the shortcut created on the desktop with the Arduino IDE. Simply double tap to open this. Come back to the same folder. Now I'm going back, IoT workshop. Let's skip this for now. And after this, I'm going to this one, that is the Proteus, right? And Proteus is the simulation software which we'll be using to simulate the electronic components, to simulate the circuits, and to create the robots also. So Proteus is a software from Lab Center Electronics, and we have maximum electronic components available here. We can test analog circuits as well as digital circuits here. So let's double tap on this. Here we have a file P7.8i. This is the seventh version I'm sharing with you. You are not required to install any license after this. If you install this software, you can work without any tension, and this is a lifetime free of cost for you. Now, if you want to use the advanced version, the latest version of the Proteus, obviously you need to install the license also. So simply double tap on this to install, right? It wouldn't ask you too many things. Simply next, 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 you have to do like this. Next, I agree. Next, and no need to mention any company name. Click next, and again next, it will install. I'm not doing it because in my case, it is already installed, right? So let me cancel this because this was the last next. After this, it will start installing the package. Okay. Once you complete this, we'll be having the shortcut icon of ISIS in the desktop. So I can't see this icon on my PC right now. Correct? Let me search IS. No, yeah, it's here. So I can start it like this. Okay. If in your case you have installed this Proteus and the shortcut icon is not available on your desktop, what you can do that time, go back to this, what you have installed. Okay. And go to C drive. In C drive, we have a folder of program files and program file 86. Simply go to 86, and in 86, we have the folder of Lab Center Electronics, and there we have a folder of Proteus 7. There we have a folder of bin, and here we have this ISIS. Right tap on this, go to show more options, send to desktop, create shortcut. So this is the way to create the shortcut of ISIS, right? I'll share, I'm sharing the location as well from where you can create the shortcut. I will tell you again in the C drive, once you install the packages, which packages? These were the packages. First, we installed this Arduino. Second, we installed this Proteus. Arduino was pre-installed actually, so we simply created the shortcut from this. And Proteus we installed using double tap. Next, next, next. Then come back to C drive. program file 86. And here we have Lab Center Electronics, Proteus 7, bin, and there we have this ISIS. Again, right tab, show more options, send to desktop, and create shortcut. A shortcut is created. Right now, when you come to this software, here we have all the electronic components available, and we simply need to pick, drag, drop, connect, play, and check the output. Right. So this blue color box where we have to drop all the components, we don't have to drop any components outside this blue box. Otherwise, they won't be the part of simulation and you will be having difficulties to connect the wires to connect the circuit, right? You can zoom in and zoom out using the scroll of your mouse like I'm doing. This is the center of my screen, right? And drag the reposition. You can do it from here like this. Left click, in left tap, hold, drag your mouse. Once you are done, release it. And then again, fix it. Now, how to pick the components? Simply go to P option, P mean pick from libraries, and it is giving you the option to search the keyword, whatever you want. For example, if you want to search a register, it's RES the register. Here we have the register, only one result, and here we have the image of register. So once you write the exact keyword of your component, you'll see the result here. You simply need to select, click OK, and you'll be able to see that the register is added in your library manager. So P mean pick from libraries, the predefined library of the software, and L mean the library manager, right? All the components which you will pick will shows in it will show in library manager. Now, when we have the register, simply select your register, come to your screen. Screen mean the blue box. Left tap, it will you will be able to see the component, and now you can drag wherever you want to drop it. Suppose I want to drop it here. I tap here, it's dropped. I want one more. Again tap, one more, and this way I can drop multiple registers. Correct. Now if you want to delete them, right tap, delete object, right tap, delete object, or select delete from the keyboard key, delete key, again delete, and delete. If you want to delete all together, select this way, like you do in Microsoft Word, and delete. Control Z is undo, Control Y is redo. How to delete all together? Select this way. Or the second option is right tap anywhere on your screen. You'll get the option of select all objects and then hit delete from the keyboard to delete all the components. Right? Now, if I pick again, suppose I need a capacitor, simply select the cap, select OK, and add it to your library manager. You can drop it. Now I'll pick two, three components together. So suppose if I need a battery, BATTERY is the keyword. Here is the battery. Not click OK, because this is the process of picking the components one by one. Now we will be picking the components all together, double tap. So it is added there. Now I need LED. So the exact keyword to search the LED is LED animated. LED animated. Because if you search only LED, it will show you the long list. And here we need to uh, sort. We need to identify the exact LED we require. So I'm typing LED animated. Why animated? Because if you want to see the LED goes on or goes off, we can see in the simulation. For that, you need to pick the animated one. And we have the color options as well: blue, green, red, yellow. Suppose I'm picking the red LED, double tap. Now, after this, suppose we need to add the motor. So simply we selected the motor, double tap, and the motor is added here. Now, if I drop the battery, suppose I'm deleting these two components. I'm selecting the LED and dropping it here. I'm selecting another battery. I'm selecting one motor and dropping it here. Right? Now, let's create the circuit. So how to create the circuit? Obviously, we need to connect the wires. So when you come to this point, I'm zooming in. When you come to this point, this is the one terminal of your battery. This is the one terminal of your LED. This one is the positive terminal of the battery. This one is the negative terminal of the battery. Right? How to identify the positive and the negative? We already know in the case of LED, it's PN junction diode, positive negative junction. So this one is positive and this one is negative. Right? And when we come to the battery, here it is the big one is the plus and the smaller one is the minus. Also, we have other option to check it. If you see if you see at this point, when I'll be putting my cursor at this point, you'll be able to see the name. So let me put it. And now you'll be able to see it's mentioned there component B1 name is equals to plus, number is equals to none. And this one is name equals to minus. So when you put your cursor, you'll be able to see the dotted rectangular. And when you see the rectangular, simply tap on that point and start moving your mouse. It will create the wire. And now come to this point and hit. Now it has created the wire. Okay. And now I'm doing it for negative also. Now I'm doing the same for motor also. Which one is positive of the motor? So this one is the positive. You can see here when I put the cursor, it's showing name equals to plus. And when I put the cursor here, it is showing name equals to minus. So let me connect this one as well. So what I have done for now, I have connected the positive of the battery with the positive of LED and the negative of battery with the negative of LED. Same I have done with the motor, positive of battery with the positive of motor and negative of the battery with the negative of motor, right? But when we talk about the operating voltage, so the operating voltage of the LED is zero point 0.7 volt to 3.3 volt. Maximum 3.3 volt we can give, which depends upon which color LED you are using. So if we are using the red color LED, that time we should give 3.3 to get higher intensity. Minimum of zero point 0.7 volt is required to turn on the LED. But currently we are giving 12 volt, which is actually dangerous for the LED. It may get fused, it may get burned. So we need to change the operating voltage from 12 volt to, let's say, 3 volts. And when we're talking about this motor, it has the operating voltage of 12 volt, right? The nominal voltage is 12 volt. So we are giving the 12 volt supply. If we give 5 volts or if we give 7 volts or if we give 9 volts to this motor, it will work, but obviously it reduces the RPM. RPM is the speed of your motor, revolution per minute. So suppose it has 100 RPM and you are giving the supply of 12 volt, which is required actually. So it will work efficiently, not exactly 100% efficient, but almost 90-95%. So if it is a 100 RPM motor and required operating voltage is 12 volt and you are also giving source of 12 volt, it will work approximately 90 rpm, 95 rpm. But if you're giving 9 volts or 5 volts, it may work or it may not work. That depend upon the size of your robot, the size of your load, and obviously size only. I mean, like when you are using the motor, what kind of load you have connected to that motor completely depends for the size of your battery, the size, speed, and the efficiency of your motor, right? So now, if I want to check the circuit, obviously I need to click play, and if I go here to hit the play option, so this is the option to play, and if I click play, I can see the LED is turned on and motor is working in clockwise direction, right? It is working in clockwise direction, and now if I want to edit the circuit, if I want to change a few part of the circuit, obviously we need to change the connections. How we can do it? Let's delete the wire. Let's delete this wire. Let's delete this wire. Let's delete this wire. But to delete, first we need to obviously stop the circuit, right? First, we need to obviously stop the circuit. So what I'm doing, I'm connecting positive with negative and the negative with positive. This is called the reverse bias. And here I'm doing positive with the negative and negative with the positive. So when we connect the motor in reverse bias, which is positive to negative and negative to positive, motor works, but in anti-clockwise direction. Correct? And the same scenario when we connect with the LED, it is called reverse bias and LED never works in reverse bias condition. Correct? So let's click the play button to check it. So now if I click play, I can see motor is working in anti-clockwise direction, but the LED is not working, which is simply showing you the reverse bias case. Right? Now, when we have a case of reducing this operating voltage, let's say I'm doing it to the 5 volts. So if I click play, I can see the motor is working with the low speed. Now, if I have to connect two LEDs simultaneously, I'm making the source 5 volts, suppose, right? Why I'm using 5 volt? Let me tell you. The maximum controllers which we are going to use further, whether it's Arduino Raspberry Pi or your STM32 or Jetson, any controller which you are going to pick, they all operates at 5 volts of operating voltage, right? And their GPIOs may even have 3.3 volt and a 5 volt. That depends controller to controller. Although we know that a motor requirement is 12 volt, a pump requirement is 12 volt, but microcontroller GPIO pins are providing 5 volts and 3.3 volts only. So how to work with them? For that, what we'll be doing for now, always we will be using the power source of 5 volt to make a good practice, right? And later I will tell you how to deal with the 3.3 volt when we have the operating voltage of 5 volt, and how to deal with the 12 volt when again we have the operating voltage of 5 volts, right? And this is completely DC voltage. So what I'm doing for now, I'm connecting this 5 volt of source with this LED. And as I said, multiple LEDs we are going to connect. So let's connect both LEDs in series and connect it like this. So now we can see both the LEDs are working. Now we already know when we connect the LEDs or any component in series, the voltage actually divides and it is divided equally. So when we connected the two LEDs with the source of 5 volt, it was divided like 2.5, 2.5. But now when we have three LEDs, it is divided like 1.7, 1.7, 1.7 equally to all. But in this case, it's not going to work. I already clicked the play button. I can see the circuit is animating, but not even a single LED is working there. That is because we have connected the source of 5 volt, which is actually not enough. Here, voltage is divided, right? So when you have to connect many more LEDs and the source is obviously only 5 volts, we can connect all of them in parallel. So let's now connect them in parallel with the source of same 5 volt, right? Although you remember, I have mentioned one thing earlier that the operating voltage of LED is maximum 3.3, starting with zero point 0.7 volt. So if you connect the 5 volt source with the LED may get fused, it may get burned. So in that case, we need to connect the resistor to reduce the current. Now it is working absolutely fine, correct? And one more scenario I'll show you, that is for the motor. So I'm picking, already we have a motor, we not need to pick. So I'm connecting this motor and here I'm connecting the source of 12 volt, right? And other motor I'll be using just to show you the different scenario when we have the operating voltage of 5 volt, so that you can compare the RPM. In both the cases, positive to positive and negative to negative, both are working in clockwise direction, but both are working in clockwise direction, but the speed of the motor which has 12 volt is high as compared to the 5 volts, right? And to check the actual logics, we need one other component which is here called logic toggle, which is here called logic toggle. So I'm going to pick one component called logic toggle. Why I'm using logic toggle? Because here we can even see the what logic we are giving. Logic means 1 0. So when we will be talking about the programming part, there we can specify the voltage because the controllers does not understand the voltage. They understand the logics, which are 0 and 1 in the form of binary. So there, if we connecting any component, we need to understand how we give the logics. So here the logic 1, I'm not giving it because it's not in the play mode, just explaining you for now. When we give the logic 1, it is equals to 5 volt, and when we give the logic 0, it is equals to 0 volt. In the binary language, in our language, when we want to give 5 volt, in programming we write it as 1. And when we want to give 0 volt, we write it as 0, so that the controller understand what actually it should provide to motor. Correct? So if we give the 1 and 0 logic, it is for 5 and 0. Motor is working in clockwise direction. And if we give the logic 0 1, motor is working in anti-clockwise direction. Why? Because in the positive terminal, it's 0 volt. In negative terminal, it is 5 volt. And 0 volt minus 5 volt, which is actually the potential difference, is equals to minus 5 volt. And that is why the direction of motor is anti-clockwise. Now, when we giving the 1 and 0, if 1 is here, 0 is here, that means 5 volt on the positive terminal and 0 volt on the negative terminal. So it is 5 volts minus 0 volt, which is equals to 5 volts. 5 volts is the positive voltage. That is why the direction of motor is clockwise. Now, if we give 0, 0, 0 minus 0 is 0 volts. So obviously the potential difference is 0. That is why motor is not working. And if even we give the 1 1 logic, that time also motor is not working. Few people think that if we give the same polarity to both the terminals of motor, it will get burned, but actually it not, because when we give 1 1 logic, it means 5 volts on the top positive terminal and the 5 volts on the bottom negative terminal. And 5 minus 5 makes the potential difference as 0. And if it is 0, obviously it's not going to work, right? So this was the scenario of understanding the basics, right? After this session, I mean, after a small break, we'll go for next part of programming. So as already mentioned in the group, you must know about that part, that once we complete 6:50. It's currently 6:50 Indian Standard Time for now. We'll go for a break of around 30 minutes because let me tell you why. Because on the other hand, we have a program for summer internship, and for that, students have their exams right now because it is for no cost summer internship, no cost summer training. So too many participants who have joined here, they are also involved in that. So they need a break to attend that exam. That exam is only for 15 minutes, 7 p.m. IST to 7:15 p.m. IST. But they need to set up the things for that. So they need almost a time of 10 minutes. So we'll be coming back and restart this session at 7:20. I'm not going to turn off the meeting. It is turned on. It is here. But I'll keep my camera off, screen off, right? So we'll start at 7:20 p.m. almost after 30 minutes. And then we'll be discussing further about the programming part and other required softwares. Before going, I'm going to quick check the messages which you are doing. But all you said, hidden while sharing. Okay, 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 sorry. So this suddenly looking. Okay, I guess everything is fine. Okay, so those all are the old messages. Okay. See, I can't re-explain the process for now. We'll come back on 7:20 IST and then I'll tell you the things again. Okay. I'll repeat the process. Don't worry. And I have already shared the link in the group. You must be in the group. So download the software from that group. Okay, fine. So as I said during the live session, I'm not available in the chat box. So now I just checked all the message. It's all fine. Okay, and also I'll be switching to my hardware very soon because a few participants asking about the hardware. So I can see it now. Hardware is also ready. I'll be coming to that point also. No worries. I'm going to take a small break of around 30 minutes and then we'll be coming back, as I mentioned, via this break. And for those who want to get the captions of this program, because I'll speak in complete English, they can turn on the captions from this application. If you have downloaded the application and joining the meeting room, you must be having the option to get the captions. So turn on the captions, right? So meanwhile, you set up your PC, you install the softwares, you download the softwares. I'm writing the link in the chat box so that you can download quickly, those who have not downloaded. And then I'll tell you the process also again. So let's install it in a small break and then we'll be coming back. Okay, guys, have fun for 30, around 27 minutes now. Then we'll be coming back. Thank you.
Guys, did anyone notice what was the process of ISI Untitled? Hello.
Hello everyone. Let's resume the session. So a few students were saying that they have problems with their installation part. Just give me a moment. I am also joining this session from other device so that I can check how it's working in between. Because as I mentioned, in between it won't be possible for me to come back to the chat box and check the things. So I'm joining from any other device just to check how the things are working. Is my screen shared? Is my camera working? Each and everything I want to be sure about. So I hope I'm audible. Am I audible? Can you please react? And can you see my face? I mean, I've shared my camera as well. Right, camera is also working, guys. Fine, that's great. Those who want to know about the sessions, they can switch to. I mean, this is in the English language, so they can also have the captions of the language. I'm repeating this too many times, so you can turn on the captions. You have option for that. Just check your application from where you have joined. Right. So I'm going to share my screen after this. So before this small break, we were discussing about the part of turning on the LEDs and turning on the motors, and also we understood how we can control the motor in clockwise as well as in anti-clockwise direction. Also, we understood about how we can control the direction of the motors using the logic toggles, right? So here are two different scenarios when we have connected motor directly with the source of 12 volt, and we can see that the motor is working in the clockwise direction. But when we connect the motor this way, in reality, we can't do this because if we directly connect the positive terminal of the battery with the positive of the motor, it will always go in clockwise direction. And suppose if I want the robot to come back to me, I want the robot to go left side or I want the robot to go right side. Obviously, we need to change the connections that time. So if we do this using the program, we can customize anytime when we want. That's why the scenario which I'm showing you here is for logic toggle. And in this logic toggle, it's a kind of logic. It's a kind of program which we are giving to a motor. When we give 0, 1, it's anti-clockwise. And when we give 1, 0, it is clockwise. And when we give 0, 0, it is turned off. Even when we give 1, 1, it is turned off. So this scenario is completely telling us how we can control the motor using the program. That is why the connection which we have done is using logic toggle. Logic mean 1, 0, and toggle mean we can switch the logics from 1 to 0 and 0 to 1. And this we'll be doing using the program. But before I start this session again, I'll again come back to the part of installation because I get too many requests. They want to install the software package and they are getting issues. So let me tell you again. Also, I want to mention you guys that don't do practice at the same time when I'm doing it because it's a virtual session and I'll be doing it continuously. So you won't get time in between to perform and to practice. But just after this session, you can practice each and everything. Even I'll share whatever we'll be discussing here. I'll share all the content with you so that you can revise. Okay. Okay. Then let's come back to the part of installation. So I told you to download the software using the link encino.in/IoT software.rar. So as soon as you hit the enter, it will start downloading the package. You can see automatically downloaded the package. I'll say keep It's not in secured files, so don't worry about it. I'm also downloading it. So simply download this, right? Once you download, I've canceled because I already have this in my PC. Now, once you install the package, go back to the downloads where you have downloaded. In my case, it's already here in the C drive, in the package of softwares. Here it is, the RAR file. Right click on the file to extract it. You must have 7-zip or WinRAR software to extract the file. Okay. If you have Windows 11, you can simply double tap because there you have the option of extract all like this. See, extract all, the default extraction software of your Windows. But if you don't have Windows 11, you can download WinRAR or 7-zip to extract the compressed file which I have shared. Once you click on this extract, you'll get a folder at the same place like this, IoT software. There, go to first Arduino IDE. It is pre-installed. We just need to create the shortcut. So right tap, show more options, send to desktop, create shortcut. And then once you are done with this, come back, go to the folder of Proteus. And in this Proteus, there we have P7.8i. Double tap on this and click next, next, next. And you'll be able to install this Proteus software. Proteus is this software which I'm using here for the simulation part and to create the circuits and to check the outputs. We already created the shortcut for Arduino, but once you install, it will not automatically create the shortcut on your desktop. So let's go to C drive, and there we have program files 86. If you install the software, you'll get this folder, left center electronics, and then Proteus 7, and then bin. And in bin, we have this ISIS. Right tap on this, show more options, and send to desktop, create shortcut. Right. This way, you'll be able to create the shortcuts for Arduino as well as Proteus. Now, the second thing is, you know, as we have to use the programming part after this, obviously we need a controller. And I mentioned that I'll not use the Arduino controller. Okay, I'll use the chip. I'll use the IC. But we need to understand the facts also. We need to understand the pin diagram also. So for that, I'm going to pick the Arduino. So let's pick Arduino. So we have too many boards of Arduino like Mega, Mini, Nano, Pro Mini, Uno. So if I select Uno and drop it to my screen, we'll be able to see it. But maybe in your case, when you install it for very first time, it won't be visible to you. This software is not visible to anyone if you have installed it for now because we need the package, we need the library package to install with it, right? How to install the library? Now let's come back to that point. So I'm coming back to the same folder where we have downloaded and extracted software. Here we have IoT software. This is the new part which I'm telling you because this I didn't mention in the last session before break. IoT software, IoT workshop. There we have a folder of Arduino library for Proteus. Double tap. Here we have two files, IDX and LIB. Right? Copy both the files. Control C or right tap, copy. Now go back to the C drive. There we have IoT software, sorry, program file 86 and Lab Center Electronics again, Proteus again. To create the shortcut, we access this folder bin. But to paste the library, we need to go to this folder, library folder, and paste your files here. In my case, both the files are already there. So it is asking me, the destination has two files with the same name. Replace the files. So I said, skip these files. But in your case, you need to uh, paste it. You'll not get this option if you already don't have this, right? Now all the installation is done for the simulation part. No other installations are required for now. Correct? Now let's come back to this hardware part, the GPIO part. So currently, the board which I have on my screen is Arduino Uno. We have too many microcontrollers. It is not only Arduino Uno. We have 8051, ABR, Jetson Nano. We have STM32, right? Microbit, and too many others. Why I'm choosing this Arduino Uno? If you are doing it from a scratch, this is the best controller board to start with. And the very best part is all the supportive packages, all the libraries which we need to install for the peripherals like GSM, GPRS, Bluetooth, Wi-Fi, IoT, AI, machine learning. Everything is available open source for this controller board. And it is very interesting part to know that this Arduino Uno is actually not a controller, it's a board. The main controller which Arduino Uno is using is AVR, right? So what I'm saying, we have too many controllers in the market which we may use, right? Let me mention here. We have 8051, we have AVR, we have STM32, PIC. One second, guys. Yeah. So we have PIC, and then we have microbit, that's a nano, ESP, too many other controllers we have, right? And still we are using this Arduino. Actually, it's not a controller; it is board with AVR controller itself. It is using the AVR controller only, right? As I mentioned, it has too many things as a open source, and it is easy to interface, easy to start with, easy to program. Correct? We need to understand the pin diagram of the board as well as the AVR, because the level which we are doing for this robotics is not the level of school. It's a level of industry grade. So obviously, I do understand if we use the Arduino boards, it is not quite good thing when we go to industry. So we'll learn how to program the chip, how to program the IC, how to program the controller, which we have inside this board, right? This would be the new thing to understand here. So using this as well as if you see the black part which I'm showing you right now, the black IC, it is at mega 328, correct? At mega 328. So we will be doing what? We will be programming this at mega 328 IC, and at the same time we have to understand the pin diagram of Arduino Uno as well. So now that would be your choice. The same program will work with both. Okay. So for first and second program, I'm doing what? I'll be programming both the devices, and later, once we understood how to program Uno, then I'll completely switch to the IC, right? Which IC? At Mega 328. So let's pick it at Mega 328. This one, 328P. I'm dropping it here. So this IC we already have inbuilt in this board, in the Arduino board. Okay. Individually, if we program the Atmega IC with Atmel Studio, which is basically the software of AVR controllers, Atmel Studio. So that time we need to write a very long program. We need to understand the supportive packages and libraries for external peripherals like Bluetooth, Wi-Fi, GSM, GPS. But if we program using the Arduino IDE, we simply need to include the libraries like hash include Bluetooth, hash include Wi-Fi, and that way. Don't worry about anything which I'm mentioning right now, because I do understand if you are starting it just as a scratch, it might be difficult to understand what all I'm saying right now, but I'll do it step by step. I'll make it very easy for you to understand, right? So let's keep it side for now, and let's try to understand this one for now. The board, Arduino Uno board. So if we see this Arduino Uno board, it has 14 digital input output pins starting from here to here. So 0 to 13, we have 14 digital input output pins, which can be used as digital input as well as digital output. Now, what is digital? Digital is simply 0 and 1. What is input? Input when you have connected a sensor or a button, and your sensor or a button is giving the logics to your board. That means the pins of your board is going to act as input because they will receive the logics from that device. If your sensor is sensing one, it will give to controller. Controller is obviously input in that case. And when your sensor is sensing zero, again controller is taking zero, mean controller is again acting as input device, right? So the pin number 0 to 13 can be used as digital input as well as digital output. Now we already understood what is input. Now let's try to understand what is output. So digital output mean again 0 1, again 0 volt and 5 volt. And suppose if you want to turn on the LED using your controller, you want to turn on the motor, or you want to turn on any other actuator, any other load, or any other coil, or any other output. So obviously your pins are going to act as digital write, digital output, or GPO, general purpose output. So GPIO mean general purpose input output pins. Pin number 0 to 13 we can use for input as well as output in digital, right? And digital mean is simple 0 1, 0 volt or 5, 0 volt or 5. Now, pin number 3, look at this. Pin number 3, I'll delete it. 3, 5, 6, and 9 and 10 and 11, right? These all the pins which I have connected for now, just to showcase you, right? These all pins can be used as one more feature, that is analog output. Analog output. So 0 to 13 is digital input and output. Digital mean 0 or 1 equals to 0 volt or 5 volt. Pin number 3, 5, 6, 9, 10, 11 can be used as analog output. Now, what is analog output? We also need to understand that thing. Digital means 0, 1, 0 volt, 5 volt, but analog can be 0 to 5 volt anything. It may be 1 volt, it may be 2 volt, it may be 1.1 volt, it may be 2.5 volt. So any voltage between 0 to 5 volt comes in the category of analog output. Why we use analog output? Suppose if you want to turn on the fan, obviously it's digital output, right? Turn on or turn off the fan is simply digital output where only you have to give 0 or 1, 0 volt or 5 volt. But if you want to control the speed of the fan, so obviously when you have to control the speed of the fan, you simply cannot write 0 1 because if you write 0 1, it will simply turn on or turn off. But when you have to control the speed, you have to write all the voltage between 0 to 5 volt. If you write 0 volt, fan is off. If you write 1 volt, fan is turned on with the lowest speed. And if you write 5 volt, fan is turned on with the maximum speed. So if you want to vary the speed, you have to write the signals. You have to write the voltage between 0 to 5 volts. Now, come back to this. Here we have pin number A0 to A5. Total 6 pins we have for analog input purpose. A0 to A5 analog input purpose. Analog input is also same. It may be any voltage between 0 to 5 volt, but we need to understand the difference between the input and the output. When we connect the LED or when we connect the motor or any other load or any other coil with your controller, obviously your controller pin is going to act as an output because it has to provide the signal to that device. But when you connect a sensor with your controller, so this time controller is going to receive the signal from that device. So the pins are going to work as input device. The pins are going to work as the input for those devices. Now again in input we have two parts, digital input, digital output. Now if we have suppose IR sensor is infrared sensor to identify the object, which means suppose if you put the IR sensor, you need to identify whether you have any object or not. But when I'm talking about temperature, moisture, humidity, I mean all the physical parameters surrounding us, when we have to measure the quantity, that time it is not digital, it is analog. You have never heard it earlier that I'm going to sense whether temperature exists or not, moisture exists or not, humidity exists or not, pressure exists or not. No, we cannot check it because I mean we don't have to check it. Temperature is everywhere. So why we are going to check temperature is available or not available? Actually, we have to check how much is the value of temperature, how much is the value of moisture, how much is air pollution, how much is air quality, how much is humidity. So that means all the physical parameters surrounding us are the analog quantities. And when we have to read these quantities, we use pins A0 to A5 of your controller board. Got it? Now, coming back to this screen, here we have the gray color connector, which is a USB connector to program this board. This black color one is basically a connector to give the power supply to this board. And few pins are missing here in the simulation screen. But if you go to check the board in reality, or if you go to check the images, there you'll be able to see the other pins also. And those pins are basically what? Those pins are basically supply pins, power pins. V input, ground, ground, 5 volt and 3.3 volts. Right? Now, if I'm talking about the operating voltage of this port, it is up to 20 volts. But generally we give 12 volt and 1 ampere using the power supply adapter at this point or a battery at these 2 points. V input is the positive and ground is the negative. So if you want to connect the battery of 12 volts, we already have, I guess, battery here. So let me check the battery. Although we don't have pin for now, we cannot connect it here. But I'm just showing you the example. If you have to connect your board to give the power supply, you can directly connect with the battery source. And how to connect with the battery? Positive at this point, at this point. Okay, this is V input, and negative at this point, the second point. Second point is the ground. So how it is? First is V input, second is ground, third is ground, fourth is 5 volt, and fifth is 3.3 volt. Right? So this way you can give the power supply to your board. And if you connect the USB cable through your PC, already your PC is giving 5 volts of supply to your board. Right? Now, coming back to understand other boards of Arduino. Now, it's like, suppose if you have a mobile phone of Samsung, you have too many series. Then you have iPhones, too many series, and so on for other mobile phones. The same way, when we are talking about the boards, the one name is Arduino, and then under that we have too many other categories: Mega, Mini, Nano, Pro Mini, Nano, Uno, right? Micro, Robo, Pilot, ESP, Note, Lilypad. Too many other boards are available. And what is the difference? Actually, they all have different features, right? Some may have number of pins 13, some may have 8, some may have 9. So as per requirement, as per your application, you have to choose your board. I'll give you one example. Suppose I'm going to pick the nano board, and if I put and on my screen, so you can compare. The size of this nano board is smaller than Uno board. The connector which we are using here to program is A to B, whereas in this board it's micro USB, right? Here we have pins 0 to 13 for digital, and the pin numbers are 0 to 13 itself. But when we are talking about this nano board, here we have D0, D1 to D12 and D13, almost same, 14 digital input output pins, right? And then here we have A0 to A5, A7. Here we have A0 to A5, only 6 analog pins. But in the nano, we have A0 to A7, 8 analog pins. So that is the difference actually. So feature wise, if you compare both the boards, the Nano is more powerful, right? But actually, the this USB port is outdated. That's why it is not being used at too many places, right? But even if I talk about the Uno board in real world application, when you are going to prepare for the actual product which you actually want to launch to the market, you are not even going to use this Arduino Uno board. That time, obviously, you will be working on the IC only, this Atmega 328 IC, right? So that's how we understood about this board comparing with the Nano, Mega, Mini, Pro Mini, right? You can drop all the boards to your screen just to compare how many pins which board have and what is actually the difference. But now I'm not going to talk any more about this board. I'll be coming to this IC. As I said, if you are going to work with the real world environment and launching the final product, obviously you wouldn't suggest this board because the size is very big. So we'll be using a very small IC of this size. In the simulation screen, it is very big size, but when you see in reality, I'm showing, if you see my face, it's simply this size of IC, right? So now, how to interconnect both? Just check it. If I see here, pin number 0, 1, 2, 3, 4, it's PD0. PD, P mean port, D mean D. We have total four ports, A, B, C, D. Correct. And in this, we can see three ports for now. P, B, port B, P, C, port C, P, D, port D. So how the pin numbers are defined? Just check it here. How to check? See, this one is PD0. So PD0 is here. PD1, PD2, PD3, PD4, PD5, PD6, PD7, and after PD7, the pins are PB0, right? So whenever we will be programming this Atmega 328 IC using Arduino IDE, we will use the reference of pin numbers of UNO, right? We will use the reference of pins of UNO, but we will connect according to Atmega 328. Okay, it would be better if I take any example to connect right now, right? So let's do that part. So I'll do what? Let's create a very first program of turning on the LED only. The very first program. I know it is basic, but let's first try to understand this. Okay. So what I'm doing, I'm picking Uno board, and on other side, I have this Atmega 328 IC, which we generally use in this Uno board, right? Now let's pick one LED. This is the red LED, and also we need to put a register. So let's put one register. One LED I am also going to drop near to this board. Okay. And one register also. Correct. Now, suppose I am going to connect this LED to pin number 13. Okay, pin number 13 is going to act as an output in that case because it has to provide the logic to LED. So the pin is going to work as output. So let's connect the pin number 13 to positive of LED. But as we know that this these pins will provide the logic of 5 volt, which is actually dangerous for LED. So we are going to use one resistor also. So let's connect one resistor, and that resistance value is 10 kilo ohms. We need to minimize this because 5 volts and 20 milliampere or 50 milliampere current only. So that time this 10K will not allow the current to pass. So that's why I'm making it 220 ohms only. You can measure it using Ohm's law, right? So I changed it to 220. How I changed it? Simply double tap on this and make it 220. Now, we need to connect this pin also, right? I'm not going to use any other pin of the controller because I don't want to waste my pins. We have to also reduce the use of number of pins, right? So what I'm doing now, I have to connect one ground here. Why ground? Because when we have to turn on the LED, we will send the logic 1, right? And we have when we have to turn off the LED, we will send the logic 0. 1 to 1, 0 to 1. So on the other side, if I connect the ground, which means if I connect the 0 logic permanently, when I send 1 on the positive terminal, negative is already 0. So the difference, potential difference is 5 volts. 5 volt minus 0 volt is 5 volt, right? And when I send 0, so 0 minus 0 is 0 volt. So when 1 0, there is a potential difference, LED goes on. When there is 0 0, there is no potential difference, LED goes off, right? So I need to connect permanent 0 here, and permanent 0 solution is always ground. So when you work with the real time, you can simply connect at this point because it's a ground point. But for now in simulation, these pins are missing. Even we not need to power this board. It's by default have the power in simulation. So this time what we can do, we need one ground. How to connect the ground? Simply right tap anywhere on your screen, place, terminal and ground. Now I have connected the ground. Okay, same connections I have to do with this also, this IC also. Now I told you simply compare where to connect. So if you see it's PB5, which pin is 13th pin? PB5, right? And here also we have a pin PB5 is this pin. That means this PB5 pin is the pin number 13 of your Arduino Uno board, right? And I'm going to program accordingly. So let's place it here and let me drag it. Let's make a space. Which pin? PB5. PB5 means this pin. Let's connect it here. Let's connect it here. Let's make it 220 ohms. And now we are able to connect ground here. So how to connect ground? Right click, place, terminal and ground. So let's select the ground from here and drop it to your screen. So now we are done with the connections for both, right? Same connections we have done. It's just it's pin number 13 here, which is actually PB5, and it's pin number 19 here, which is actually PB5 again, right? Now we have to program this. Okay. So before we go to programming, we also need to understand the basic of programming, right? Now I'm coming to this part, how to understand the basics of programming. So whenever we start the programming with the Arduino IDE, there are, let me show you here. I have opened this Arduino IDE. How to open this? Simply, we have created the shortcut in your PC. So double tap on that icon and it's open, right? Once you open this, after that you'll be able to see the programs and you'll be able to create the programs also. Simply go to File, click New, and the very first time when you open, it's completely blank with only two loops, which is void setup and void loop, right? So come back here. We have two predefined loops. Void setup we use to write and run your code only for once. This is once, and void loop when you want to run your code for infinity period of time. So we use this for one time and the loop for infinity period of time. Suppose you want to turn on the LED only once, you need to keep your code here. If you want to turn on an LED for infinity period of time, you need to put your code in the loop, right? Now, what is this? This is to tell you that code starting, program starting, loop starting, and this loop ending. What is this? Comment. Comment mean just writing it for understanding. It's not part of execution of the program. And what is this? This is the calling of your loop. It is calling a function. You are calling the function. And if you put semicolon in front of this, that means you are terminating that function. So never put this semicolon in front of void setup or void loop. Correct? It will terminate the function. Now we have data types. Data types like we may have data like 1, 2, 3. So we write it integer. We may have data like 1.2, 1.3. So we can write float. We have data like 3, 4, 5, 6, 7, 8.529, which means long data. So we can write it long. And we may have data like ABCD, right? So it's called string. We may have data like A or B or C. It's character. So when I'm talking about a single alphabet, it's a character. When I'm talking about a set of character, it is called string. So these are basic of data types, right? And these are the data types which we use to mention to write a kind of data. Now, further after this, when we have to define the mode of the pin, suppose you are using your pin as output or your input, we have a diff command which is called pin mode. Pin mode. And in pin mode, we can write, suppose, variable, comma, it is output or input. Then if you have to turn on the LED or turn off the LED, or if you have to turn on the motor or turn off the motor, we give the command using digital write. Okay. When you are using your pin as output or input, you can define using this command because I said pin number 0 to 13 can be used as input as well as output. So when the pins are for both the operations, so we have to choose only one at a time. Suppose if you are using as input, need to write input. If you are using as output, need to write output. And what is variable? Variable basically you declare during the program, right? And digital write is what when you have to write the logic of 5 volt or 0 volt. How we write it? Using variable, comma, high or low. High mean 5 volt and low mean 0 volt. High mean logic 1, low mean logic 0. And when you want time difference between two conditions of output. For example, the output is on and after 10 seconds, you want to turn off the output. So that 10 second is basically a time duration and that time duration is actually a delay. And for that delay, we use a function, we use a predefined program, we use a predefined command, which can be defined as delay. And whatever delay you want to write, you can write in this way. And the unit of this delay value is in milliseconds. If suppose you have to write the delay of 1 second, you need to write it as 1000. That's it for now, right? Now coming back to this, we have connected a LED at pin number 13. Do remember, okay? And we are going to write the program according to that. So I am writing the program here in void setup. First I am writing int LED equals to 13. Why I'm doing this? Because we have connected the LED at pin number 13 and LED is not predefined here. So I'm defining a variable LED. The data type is integer because 13th is the integer number. Okay. So the what is the meaning of this line for now? It is LED is a variable which we initialized with 13th and it's a kind of integer. Now let's come to void setup and here we need to define the pin mode of this 13. As we know, 13th is connected with the LED. So obviously we are going to turn on the LED or we are going to turn off the LED, which means that pin is going to act as output. So we have to write pin mode LED comma output. Right. Now if you want to turn on the LED, write digital write LED comma high. Got it? What was the command? It was simply digital write variable comma high or low. So variable we have defined as LED, and if we have to turn on write high. If we have to turn on write low. Again here variable is LED, and we are using it as output. So we have mentioned pin mode LED comma output. It's not mandatory to write LED itself. It's not like you have connected the LED here, so you have to write LED only in the program. You can also write A. But if you write A, it should be same at every place. It should always be A. It should also be A. So we are done with the program. Let's save it. To save, simply Control S or go to File and click Save. Now, this is very important part. Do remember this because when we are going to save the program and we have to run into this simulation circuit, we need to actually find out the exact file. So do remember where you are going to save your code. So the best practice, which I usually do, I'm suggesting the same to you also. Go to desktop, create a new folder, and let's name it Robo Workshop. I'm naming it with the Robo Workshop. Okay. You can mention any name to your folder. It's not mandatory the same name. Open the folder. I'm doing it very first program. So I'm writing it P1. Now I'm going to save my program in the Robo Workshop folder of desktop location with the name P1 and let's save it. Program is done. The program which we are writing in language, it is called embedded C++ language, right? But the machine which we have does not understand the C language or embedded C language. It does not understand actually. So which language it understand is binary language, 0 1 language. So obviously now we need to write the code in 0 1, but it is not possible to convert the whole code in 0 1. So we will convert this code from human understandable language to machine understandable language. For that, we need one compiler which is already installed with the software. So we not need to do anything after this. Simply let's compile the code. Compilation is the process to check the errors in your code. Also to convert the machine understandable code into the human understandable code into the machine understandable code. How to do it? The one option is to verify from here, and the second option is sketch export. But we will not compile from here because if we compile it from here, it will compile the code. It will also convert the code, but the file, binary file which we need or the hexadecimal file which we need to run will be in the temporary folder of your PC. And to access the temporary folder is quite difficult every time. I mean, it's not only about one time. If it is about one time, we can do, but too many times we need to do that. So that's why don't compile from here, compile from this sketch, export compiled binary. Now it is compiling the code, it is compiling your sketch. Once it is compiled, and if we don't get any error, it will show us the message done compiling. If we write any mistake in the syntax of the code, it will show us the error here. For example, right now it is absolutely fine. It should show us done compiling message here. But just after this, I'll make a small error and show you how to identify the errors also. So for now, we can see it's saying done compiling without any error. Let's delete this and again go to sketch and export. Now it is again compiling the code and it will tell us that we have missed the semicolon. So what is the error? If you zoom it, it is saying expected semicolon before curly bracket token. The line is also red. It has pointed the cursor at this point that before this curly braces, you need to put semicolon. So let's put it again. Let's go to sketch again. Let's again export it. Once we export, we need to go back to, once it is export, we need to go back to circuit. So it is done compiling. Let's come back to Proteus. Now let's try to understand the next process. Double tap on this because we have to run the program. So double tap on this. Click browse to get the program file. This is the option to get the program file. Browse, where we save the code in desktop, obviously. So let's go to desktop. In desktop, the folder was, I guess it was Robo Workshop. So simply go to Robo Workshop. There we have P1, the name of the program. Open this. So here we see p1.eno.standard.hex. P1 is the name of your program. Eno is the extension of Arduino file. Standard mean the file created for Uno code, and hex mean hexadecimal file. So let's select open, OK, and click play. For now, it will give us the error. Error is AVR program properties not defined because here also we are using the controller which is not programmed. You programmed this one, but you didn't program this one. So it is giving us the error. If I delete this and click play, I can see it's working now. The LED is turned on. But I want to work with both, right? So now if I double tap here, I can again map the program to this board, same ways, program files, and the folder was in desktop with Robo Workshop, P1 and p1.standard.hex. Click OK and click play. Right. So now we can see both the places the LED is turned on. Same program, different controllers, and it's working. Right. Now, suppose if we want to change the code a bit, for example, if I'm doing it delay of 1 second, and let's turn off the LED, digital write A comma low, sketch export. So what we are doing, we turned on the LED and after 1 second, we are turning off the LED. So let's come back, click play. So look at this, LED is turned on and after 1 second, the LED is turned off. But if you see at this point, the LED is not turned off till now. Let me play it again. So at this point, the LED is turned off after 1 second, but at this point, the LED is not turned off. So actually what we did, we simply write the code to turn on the LED and after 1 second, turn off the LED and we again sketch and export the code. Why we exported? Because we updated the code to create the new hex file, right? But when we come back to this window, we didn't updated the code like this because we don't need to update. It already has the location of your code. Once your Arduino ID will provide you or compile the new file, it will automatically pick from that location, which we already have here, right? So we not need to do this again and again until we change the name of the program from P1 to P2 or P3 or P4. So if I go to play, I can see the LED is on, but in this case, the LED is on but not turned off after a second. Why this is happening? This we need to understand, because this was a complete board, which is actually called a development board. But this was simply a IC which we were programming. And if we discuss about the clock frequency of both right now, so they both have the clock frequency of 1 megahertz, which is 1 million clock pulses per second, which we can increase up to 16 megahertz, which means 16 million clock pulses per second using external crystal oscillators. So when we are talking about this development board, it already has the crystal oscillator circuit inbuilt with this. And crystal oscillator circuit is to work with the clock frequency. And until and unless you don't have the clock frequency in your controlling board, it cannot work with the delay functionalities. So right now, when we are talking about this board, it already has the clock frequency because it has the crystal oscillator. That is why it can understand your delay function and turning off the LED after 1 second. But when we are working only with the IC, it does not understand your delay function. That's why the LED was not turned off just after a second. It took too much time to turn off the LED because 16 megahertz clock pulse is not working here. You have not connected any crystal oscillator. So now we need to connect one crystal oscillator with this circuit, and then it will work same like your board. Got it? So how to do it? Let's go to pick the component. How to pick the components? Either from this option P, or otherwise you can also hit P from your keyboard. So I'm hitting P from my keyboard and writing crystal. So here we have crystal oscillator, and for the crystal we also need the capacitors. So let's now connect crystal here, rotating it. Where to connect the crystal, this also we need to understand, right? So whenever we have to connect the crystal, here we have two pins, this XTAL1, external crystal oscillator 1, external crystal oscillator 2. These are the pins where we need to connect this oscillator. So one pin at pin number XTAL1 and the other one is to XTAL2. Now we also need to connect the capacitors. So capacitor, we also need to understand how to connect. Actually, we are not getting too much space. So how to do it? Let me drag this to left side. And now let's drag the whole process to this side. Right now, let's zoom in. Now we have enough space to work with. Now what I'm saying, we have to connect the capacitor. So I'm coming to capacitor and let me drop it. Now let's check the positive and negative of the capacitor. I'll put my cursor here, you check here. Okay. So if it show name equals to 1, that means positive. If name equals to 2, that means negative. This is the special case for capacitor. How to identify positive and negative? If you put your cursor here, it will show the name here at this point. So currently when I'm putting my cursor, it is showing name equals to 2, which means this one is negative. So right click, rotate 180 degree, and now if I put my cursor, I'll get name as 1. So let's connect the positive here. And now again capacitor, again it is negative. So right click 180 degrees and now connected the positive to other terminal of crystal. And both the terminals we need to connect with the ground because these both are negative terminals. Now let's change the parameter value of this capacitor. We need to change the capacitance from 1 nanofarad to 22 picofarads. So now as we have connected the external crystal oscillator, it must work because we discussed about the clock frequency. So we have connected this. Now let's click play. So it's turned off after a second, but again, it's not turned off after a second because it's not only about external crystal oscillator. We also need to change the fuse settings of this controller. And how to change these settings? As I mentioned, I'll do this board only for 1 or 2 programs. After this, I'll completely switch to this one. So you need to understand how we connect in this IC, because when you are going for the final product development, you won't have to use this board. You may use the IC like this. And whenever you program the IC, you need to understand the other connections as well, like I'm doing the other settings as well. So now let's do the other setting of this. So we need to do what? As we have connected the crystal oscillator, so let's say each and everything is unprogrammed. Each and everything is unprogrammed. And after this, I'll say the clock fuse as 1011 external crystal oscillator and clock frequency as 16 megahertz. M capital H capital Z small. Click OK. Now, if we click play, let's check both the circuits simultaneously. If I click play, I can see both the LEDs are on, and after a second, both the LEDs are off. So now it's working absolutely fine. Correct. Now let's come back to the code, and I'm saying what? Copy the code, not copy actually. Cut the code, paste to loop. Okay. Now we want it to turn on the and turn off for infinity period of time. So I'm writing one more delay here, and what we said, turn on the LED. After a second, turn off the LED, and after a second, repeat the process as it is in the void loop. So repeat the process for infinity period of time. Now let's go sketch, export, as we have not changed the name of the code from P1 to P2. So we not need to again upload the code to the controllers. Simply stop and replay. So if you replay, we can see LED is on, and after a second LED is off, and after a second LED is again on, and after a second LED is again off. And this process goes on for infinity period of time, right? What we can do after this, if we change it to suppose 100, 100, sketch, export. So 100 milliseconds, that means we have reduced the delay. So now it's continuously working. LED is turning on, turning off, turning on, turning off for every 100 milliseconds and for infinity period of time. Right. So we are done with the very first code, and I hope you understand what we have done here. If you have any questions, you can ask. You can unmute and ask. Okay, I guess no questions. So we should switch to the next part. Right. As we have focused on the IC, so let's delete this. Let's delete this as well. Right. And now we will be talking about this one only. Right. Also, if you want to save the design, simply go to File, Save Design, and I'm saving it to Robo Workshop. Here I'm creating other folder of designs. And this design we are doing for P1. So I say P1 design. Right. Now let's create a new file. Okay. So let's do the same process again, but this time not with the LED. This time we are going with the motor. As we have to approach to robotics, so obviously it should be motor now. Pick again at Mega 328P. And then we are going to pick motor, and we need crystal also. So let's pick crystal. Let's pick capacitor. That's it. At Mega 328, we dropped motor, we have dropped, right? And we need crystal also. So let's drop the crystal. Rotate clockwise, and we need capacitor. So let's drop two capacitors here. This one is positive, positive, and this I'm connecting to crystal. This I'm connecting to capacitor, and these two pins we need to connect with ground. So let's pick the ground. Two ways we have to pick the ground. Right click, place terminal, and ground. Correct. And the second option we have is this one, ground. Right now, I'm connecting PB4 and PB5 with a motor. Okay. Why I'm using both the pins for the motor? Because we have to rotate the motor in clockwise as well as anti-clockwise. So if you have to rotate both direction, obviously we need to use both the pins. So PB4 is pin number 12 according to UNO. If you don't understand, you can do one more thing. You can drop the UNO board also just to compare, not to connect with any components, but just to compare. So PB4 is pin number 12 and PB5 is pin number 13, right? So I'm connecting PB5 with the positive and PB4 with the negative, right? But we are doing it wrong way for now because we have already discussed the nominal voltage. The operating voltage is 12 volt, right? And the operating voltage of controller is only 5 volts. So how we can operate the 12 volts of motor directly with the 5 volt of port? 5 volt of IC. That would be difficult for the IC to provide the enough amount of voltage, and that would also be difficult for the motor to understand the 5 volt because it requires at least 12 volt. And if we give 5 volt, obviously it won't give us the 100% efficient output. It may be 50%, maybe 10%, maybe 40%. So now what we need to do actually, we need to connect one motor driver IC along with this. And there are too many motor driver ICs. I'm talking about the IC which we have available in this simulation, L293D. In reality, when you go for the product development, I do not suggest to use this L293D. I do suggest L298N if you have the small motors of around 12 volts of 1 ampere. L298N, because that has a heat sink process, also it can operate at the high current of almost up to 3 to 5 amperes, right? So let's delete this. Let's delete the connections for the motor and then let's pick one L293D. All now we need to understand the connections for the L293D, right? So I'm dropping it here. First, without the board, we will understand how this L293D IC works. When we understood this, then we'll come back to the connections of program. Okay. So let's drop this motor here. This is the positive. I'm connecting with this pin and negative. I'm connecting with this pin. Okay. Now, why I'm connecting at this pin? Because this is the output one and output two. This L293D IC has four output pins, and there we can use two motors simultaneously. Output one, output two for first motor, output three, output four for the second motor. For now, we are just taking example of one motor. Now, how this output 1 and output 2 operates the motor? For that, we have two input pins at input 1 and input 2, right? So I'll do what? I'll pick one more component called logic toggle, which we have discussed earlier before break. Logic toggle, just to understand, we are giving logic 1 or logic 0. So without program, we will first test the motor for both the directions. And once we understood, then we'll apply the programming with this IC. So now let's just try to understand how this IC works. See, this logic toggle is going to give the logic of 5 volts, the signal of 5 volts, same like this IC. But this motor required 12 volt. So what this IC is going to do in between, it is not going to convert your 5 volt into 12 volt. It is not boosting the voltage. It's not a voltage booster or a buck converter. What this IC will do, whatever logic you pass at input 1, if it is 1, or 0, it will pass the same logic to output 1 or output 2. Correct? But but what signal voltage we are giving here is 5 volt, but this IC at output 1 and output 2 will provide the 12 volt. How? Because I mentioned this will not convert 5 to 12. How? Because we need to give the external source of 12 volt to this IC. So I'm connecting the power terminal. How to pick the power terminal? Right click, place, terminal, power. Or the second option is this terminal mode and power. So let's drop the power. And this default power is 5 volt. So I'm making it 12 volt. How to make it 12 volt? Double tap and type plus 12 volt. Plus is mandatory to write. Okay. And again, one source of 5 volt and one of ground. Now let's understand each and everything quickly. To give the energy to this IC, we have connected the 5 volt source to pin number 16 of the IC and ground at this pin. So if we give this power and ground, this IC is energized. Now we are giving this external 12 volt of supply to pin number 8 of L293D so that it can pass this 12 volt to the motor, but not always. when it has to pass this 12 volt when we provide the logics at input 1 and input 2. So whatever logic we pass at input 1, it will pass the same logic at output 1, and whatever we pass to input 2 will pass to output 2. That means output 1 and output 2 will get the logics from input 1 and input 2 respectively. Difference is that here we have the 5 volts and here we have the 12 volts because of this 12 volt external supply. So we can simply say this L293D motor driver IC is acting as a bridge between the external battery source of 12 volt and motor. It's a bridge between the battery source and the motor, right? So this bridge is working when you give the logics at input 1 and input 2. Right now, according to the hardware connections, we have to connect this enable 1 pin with the source of 5 volt to enable all the pins for the motor 1. All the pins for motor 1 are output 1, output 2, input 1, input 2. If you connect one more motor, you have the option of output 3, output 4, input 3, input 4. But in that case, you need to enable all these pins using EN2 pins. So that time you need to connect EN2 with 5 volt source. But for now, we not need to connect. So let's delete it. Now, if I click play, obviously it will give us the error, and the error is because of this board or this IC because it's not programmed. So I'm deleting it for now. Okay. And now let's click play. So now I can see if I give the logic 1, 0, motor is working in clockwise direction. And if I give the logic 0, 1, motor is working in anti-clockwise direction. So 1, 0 is for clockwise and 0, 1 is for anti-clockwise direction. I do understand, like when I am doing this simulation at my screen, motor is working absolutely fine, rotating very well. But I am sharing my screen, we are on the meet. So there it may lag. I do understand. But trust me, when you do this on your screen at Proteus software, you'll be able to see it very clearly. Correct. Now, the next part we need to discuss is what? Let's suppose if I'm connecting one IC. So Control Z, I have the IC now, right? So IC role is what? Now let's delete these two logic toggles and let's implement the same connection here because IC is going to give 5 volts as we discussed, and we have this L29 to give the 12 volt supply to motor using external source. We'll do same. We just replace the logic toggle with the program mean the programmable IC, and that is at Mega 328 for now. So now let's connect PB5 mean pin number 13 with input 1 and PB4 that is pin number 18 with input 2. 18 and 19 with respect to this IC, but actually these pins are 13 and 12. See, PB5 is 13 and PB4 is 12th pin, right? So when we program, we have to program it according to UNO board, right? So let's come to this screen now. I'm going to create a new file. Let's close this one, right? So now what I'm saying, int motor positive terminal is connected to 13. See, look at this. Motor positive is connected to output 1. Output 1 will get the logic from input 1, and input 1 is connected to PB5, right? And PB5 is pin number 13 according to UNO, right? So let's say MP to 13 and int MN to 12. You can also do this way, comma mn equals to 12. So what we have said, we have two variables, mp and mn. mp is positive, mn is negative. Positive is connected with 13, negative is connected with 12. Now let's define the pin mode for both. So I'm saying pin mode 13, comma, mp, comma, output, and pin mode mn, comma, output. You have to write small because it's a predefined. So if you error. Now, when we have to turn on the motor in clockwise direction, for clockwise, here we need to give logic 1. If we give the logic 1 at this pin, which means positive pin should be 1. So let's write MP comma 1. You can also write 1 here. You can also write high here. It's your choice, whatever you write. So now I'll make it short. So I'll do it 1. And digital, write mn comma 0. Then let's write a delay of suppose 2 seconds. And then I want to switch it to anti-clockwise direction. So digital write MP comma low or 0 and digital write mn comma 0. We are done with the coding, right? So 2 seconds clockwise and 2 seconds anti-clockwise we have said. So let's save the code in the same folder desktop, Robo Workshop, and the program name I'm doing is P2. Once we are done, simply export the code. And if we have exported the code, obviously we need to come to this screen, right? And here we need to write the code on this. So double tap on the controller IC, program file. Program is in P2 standard hex. Let's set each and everything 11111, and this should be 1011. And here I'm writing 16 megahertz. Now, if I play, we can see motor is working in clockwise direction, and after 2 seconds, it should come to anti-clockwise direction. But actually, it's not coming to anti-clockwise direction. Always it's going clockwise, and 2 seconds clockwise and 2 seconds stopped because in the code we have set 00 by mistake. So it should be 01. Now let's export the code. Again, stop your simulation. And once the code is compiled, again click play. And now the motor is working 2 seconds clockwise and 2 seconds anti-clockwise, right? So this is how it is working. I do understand again the same thing that in case of screen sharing, it might not be visible clearly to you guys. So just give me a sec. What I'll do for you, just give me a sec. I'll do what? I'll record a small video for this, okay, and share it with you in the group so that you can see how it's working with the program. Very small video of 4 seconds almost. Look at this now. The result is clearly visible to the video which I have recorded, and you can see that video in the group I have shared. Right now, I'll ask you questions. If you have any questions, you can ask me. Then we'll switch to the next part. I have questions like, but sir, LED is also support 5 volt. Mr. Kamal, LED, the LED which I'm talking about is having the operating voltage of 3.7 volt to 3.3 volt. If you purchase the LED of 5 volt, then you need to write directly 5 volt. Even you have the LED for 12 volt and 24 volt also. But generally, when we start with the electronics and talking about the LED, it has the operating voltage of only 0.7 to 3.3 volts, right? That's why we use the resistor. So I did not understand what to do after after writing the code in the Arduino IDE. So I guess I have done this process 3 times, and this is very old question. So I guess it is now clear to you. Okay, and do not understand the crystal oscillator. Redo the steps. I have already repeated the steps for crystal oscillators. So I guess you have also understood this. How to upload the program to this circuit is I'm telling many times. Okay, let's do one thing. I'll switch to the next program and that time try to understand whatever you have not till now, right? So now I'm doing what? I'll make a small program with two-wheel robot. Okay, let's say a two-wheeler. Okay, two-wheeler mean the bike or the car. Sorry, not car, bike. And this two-wheeler we are doing with the electric one and the automatic, not the automatic one for now. It will go forward, then backward, then left, and then right. This way we'll do. But when we are talking about the two-wheeler, It's forward mean both the motors are clockwise, and backward mean both the motors are anti-clockwise. But left right cannot be done, because when we going left, both the motors going, left right can be done using the steering part, right? So that's not very much interesting. When we do the four-wheel robot, that time we'll understand the left right operation as well. For now, when we are doing with the two-wheel robot, so we'll do only forward and backward operation. Okay, so both motors forward, both motors backward. So what I'm doing, I'll do one more motor, connecting this with output 1, output 4, output 3, output 4. Okay, and this pin ground as discussed. And as we discussed, if we have to use output 3, output 4, obviously we need to use two more pins, input 3, input 4. So let's connect input 3 and input 4. So input 3 I'm connecting with PB3. Do remember, input 3 I'm connecting with PB3, and input 4 I'm connecting with PB2. Okay, look at this. I zoom in the circuit. PB5 is connected here. PB5 is connected. This wire. This wire is connected with IN1, which is motor 1 positive, and motor 1 negative mean output 2. Output 2 with input 2. Input 2 mean this is PB4, right? And now PB3 is this wire, and this is connected with the input 3. Input 3 mean the positive of second motor, and then PB2 is connected with the IN4, and IN4 is connected with the output 4, mean the negative of second motor. Right? Now, what I'll do the programming part. Okay, new file I'm creating so that you can understand the process. Those who have problem understanding the process, how we are doing it, for them I'm repeating it. Just give me a second. I need to connect the charger to my laptop. Okay, so let's program this. We have connected PB5, PB4, PB3, PB2 respectively, right? And let me tell you the numbers again. So PB5 is pin number 13. Look at this. PB5, PB4, PB3, PB2. Right? 13, 12, 11, 10. Where 13 is the positive of motor first and 11th is the positive of motor second. Right? Let's write the code. So I'm writing int motor 1 positive equals to 13, comma motor 1 negative equals to 12. Then int motor 2 positive equals to 11, motor 2 negative equals to 10. All the pins we are using as output. So let's write pin mode for all. So M1P, comma, output. Let's copy the line to reduce the timing. I'm just pasting it and changing M1N, motor 1 negative, motor 2 positive, motor 2 negative. Right? It's not mandatory to use the same variable as I'm doing. You can use A, B, C, D also, right? But why I'm doing this? So that we can relate actually what we are doing. It's motor 1 positive, it's motor 1 negative. So it's quite easy to understand. Now, what I said, we will use both the motors clockwise, then both the motors anti-clockwise. So it's very simple. For two-wheeler, we have said, right? We have motor 1 positive, motor 1 negative, motor 2 positive, and motor 2 negative, right? When we have to go clockwise, what is the concept? The concept is simple. When we have to go clockwise, the positive pin should get logic 1 and negative should get logic 0. Same here. So this is for clockwise. And anti-clockwise, when we have to operate anti-clockwise operation, positive pin should get 0 and negative pin should get 1. So it's same for both. So we can say this is what? This is the forward operation, forwarding. And this is backwarding, reversing operation. backward. Correct? So what are the logics for MP1, M1N, M2P, M2N? It's 1010 and 0101. So this way we'll write it. Only one line I'm going to write, digital write, motor 1 positive, comma 1. And then let's copy this and paste 4 times. Right? Now, if we come back, when we pasted it, we need to edit, right? So let's edit the process. M1P, M1N, M2P, M2N. So M1P 10 and M1 10, right? M1P is M1P, M1N, M2P, M2N. It's respectively 1010. Now after this, let's take a small break of 2 seconds, a delay of 2 seconds, and copy this whole and paste it again. And let's say 0101. So 1010 is for clockwise and forward, and 0101 is for backward. So let's write it here. I'm commenting the process also, forward, and this process is for backward, right? What we have done, 1010 So for those who didn't understand how to compile the code, how to save the code, how to generate the hex file, how to upload the hex file to IC, and how to set the settings of the IC, now they can understand again. The process I'm going to do again, right? Control S to save in desktop, same folder I'm using, Robo Workshop. There I'm writing the code as P3, saved. Now go to sketch, export. So export will generate the hex file. You don't have to compile from this icon, okay? Because it will generate the hex file in temporary folder, which would be quite difficult to access. That's why you have to export using this option. Now, once you see the message done compiling, minimize the code and come to the screen. This is screen where you have the circuit. Okay. Now, double tap on this board. Here you have the program file option. Here you have the browse icon. Browse it. Go to your folder. It's what? Robo Workshop P3. There we have p3.eno.standard.hex. Hex mean hexadecimal. Standard mean you are creating for Uno board. INO is the extension of Arduino IDE sketches or files. P3 is the name. Select your file. Click open. After this, make all the settings to 1, 1, 1, 1, 1, unprogrammed. And then this clock fuses is 1011 external crystal oscillators of 0.923 megahertz. Although we are doing it for 16 megahertz, so let's write 16 megahertz manually here. And then click OK, click play. So now we can see both the motors are going clockwise direction for 2 seconds and then anti-clockwise direction for 2 seconds. Again, same thing. Same mean like you can't see exact in your in this screen because it's meeting, live meeting, and animation get may fail. But in reality, when you will be doing this in your screen, you'll be able to see the output, which I have just recorded and shared with you. This I'm not doing because it will waste too much of our time to do the same practice again and again. So now I'll ask each and everyone, do you have any questions now? Now we have done the programming of two-wheel robot, and after this, I'm quickly switching to four-wheel robot. So if you have any questions now, you can ask. Digambar, I can share each and every code, each and every circuit, right? But I won't because if I share the codes, if I share the circuit, you'll not do anything by yourself. You'll simply open the circuit, paste the code, and work it, which I don't want. If you are here to learn, try to understand how we are doing it. Try to create your own codes. It will help you. That's why I don't want to share anything. Kamal, if you want to identify the register, obviously you have Ohm's law V equals to IR, and using that you can identify. Also, you need to understand about the power, wattage, how much power you have. And for that, which amount of register you need. And I guess now, Digambar, you already understood how to upload the code, right? Vignesh, you also understood how to upload the code, I guess. Digambar, I have already mentioned that just try to learn, just try to monitor what I am doing. Don't do the same things right now because I do understand this would be quite difficult to perform the same circuit with my pace, right? So right now, don't do anything parallelly. Just focus on what I'm doing. After the session, definitely I'll share all the data as I mentioned. Data mean not the circuit, not the code. I'll share the whole video recording of the session so that you can revise. But for now, why we are doing this live? Because you are understanding the key concepts and whatever doubts you have in between, you can ask me directly. Later, you have to simply check the codes, check the circuits because you already have the knowledge. Vignesh, yes, right. Good question. I have not connected the EN2 pins. I missed it. But trust me, in reality, if you missed it, in hardware, if you missed it, your motors are not going to work. This was the simulation, it was working, but later, when you work with the hardware, it won't work. So you got the good point, Vignesh. We need to connect the EN2 as well. Good question. Raunak Kumar Rai, we are not here to please discuss about the internships. Let's please focus on the session, what we are doing for now. We can discuss that later. Yes, Shalini, we'll share the recording also. Don't worry. Okay, now let's hold it here, right? Those who are leaving the sessions, hearing that I'll share the recording, they won't get the certificates. To remember this, okay? You have to be here and show your presence. Okay, now let's quickly go to make a four-wheel robot. Okay. And when we have to make the four-wheel robot, the very first thing which we need to understand that in a four-wheel robot, we have four wheels, obviously. And for four wheels, we need to connect four motors, obviously, right? I'll stop sharing my screen for first 5 minutes, right? So that, am I visible? Can you see me? Please give thumbs up. Good. Okay. So let's say that this is a four, not why to pick this when we have a real robot here. So let's say we have a robot, right? And this is four-wheel robot, correct? It is a four-wheel robot, right? So how we have four wheels? One, two, and three, four. Now let's say this is front side, this one is the back side, this one is the left side, and this one is the right side. So when we have to move this robot to forward direction, all these two are going clockwise, forward direction. When we have to come to backward, all these four motors are coming to anti-clockwise direction. Correct? This was the process of doing forward and backward. Clockwise, clockwise, forward, anti-clockwise, anti-clockwise, backward. Right? Now, just imagine when we have to move this robot to left direction. Left mean this way it has to go. So when this robot has to go left side, the left side motors should be stopped. And please turn off the camera, Joshua. The left motor should stop. Okay. And right motors clockwise. So this way the robot will move to left direction. Just imagine whichever direction you have to go. If you want to go left side, stop the left motors. If you have to go right side, stop the right motors. Right? Whichever side you are going, if you stop that motors, that side will be stable. Suppose I'm going left side. Okay. So this is the left side. If these motors are stopped and these are working, so this part is stable, this part is moving, so it will go like this. And vice versa. If this part is stable, this part is moving, so it's going like this. So left, right. Okay. One more thing you can do. If you have to go left side, either stop the left motors or move the left motors anti-clockwise. So for sharp turn, move the left motors anti-clockwise, and right motors clockwise for left operation. And for sharp turn, right side, move right side anti-clockwise and left side clockwise. I'll conclude in one line. For forward, all these motors are moving in clockwise direction. For backward, all these motors are moving in anti-clockwise direction. For left side, left motors are stopped, right motors are clockwise. For right side, right motors are stopped, left motors are clockwise. And for stop, all the motors are not working, all the motors are stopped. Right? I hope you understood this concept. Now, what we will do, we will very quickly create the circuit and simulate this. Right? So, first, I'm going to share my screen. So, one more thing we have noticed when we are going left side or right side, both left side motors are working same always. Right side motors are also working same always. That means if left motors are working same, we can short them. So what I am doing for now, let's delete this. Or let's delete this. Let's delete this. Let's delete this. Okay, and drop two more motors to make a four-wheel robot. Now these two are suppose left motors, and these two are suppose right motors. And also let's mention this is the front side of your robot. This is the back side of your robot. So if this is front and this is back, obviously this side is the left side and this side is the right side. So these two are left motors, these two are right motors, these two are front motors, these two are back motors. In all the cases, when your robot was going forward, backward, left, right, both left motors working together similarly, and both right motors were also working similarly. So let's short them. Why I am shorting? Because I don't want to use one other IC because this L293D IC supports only two motor at the same time. But if we short, according to the IC, it's only one motor because we are giving the logic only once, right? So what I have done for now, left side positive is connected with output one is input one, same like the last one, and output three is now I'm connecting with wait. Need to maintain the gap for both the motors. So let me drag both the motors. Done. And now positive to positive, negative to negative. And this output 3 is with positive and output 4 is with the negative one. So now we have done creating the circuit for a four-wheel robot. Got it? Simply now we need to create the program and this won't take too much of a time. It will take only 2 to 3 minutes to create the complete program, right? But before directly we moving to the program, first let's try to understand the concept here. Okay. Now I am changing the variables. I am saying motor left positive, motor left negative, motor right positive, motor right negative. And how these are connected? These are connected in this way: 13th pin, 12th pin, 11th pin, and 10th pin. Right? And now let's write the whole logic. For forward, this is 1, 0, 1, 0. Both motors, both side, left motors, right side, clockwise. Backward. Backward is 0, 1, 0, 1. Both left and right side motors are anti-clockwise. Correct? Now, leftward. For left side, as we discussed, left side motor should not work. So 0, 0, because these two are left side motors. So it should be 0, 0. And right motors clockwise. And for right side, it is 1, 0, 0, 0. Correct? For right side, right motors are not working and left motors are working in clockwise direction. Right? Now, let's stop the robot. So 0, 0, 0, 0. If you understood these pipelines, You understood the whole code. Okay. Now I'll write this code once again from the beginning, from the scratch, so that if you have any questions, you can ask. But I'll do it in 2 to 3 minutes, very fastly. Int MLP is equals to 13, motor left positive 13, comma, motor left negative equals to 12. Int motor RP, motor right positive equals to 11, comma, motor right negative equals to 10. Then we need to define the pin mode for each and everything. So pin mode MLP, comma, output. And let's copy this. So now it should be MLN, MRP, MRN. Okay. And after this, digital, right, MLP, comma, 1, copy, paste, paste, paste. Okay. I'll explain it. Don't worry. First, let me set all the variables MLP, MLN, MRP, MRN. So now let's understand the whole code. According to this, I'm writing it. Okay. You can compare it here. Okay. 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 1 second. I'm setting it so that we can see both on side screens. Right. So I'll write the code here. You compare it from here. Okay. So first I'm writing it for clockwise, mean forward. So let me comment also forward. It's 1010 and then delay of 2 seconds. Then let's write it for reverse, backward. Copy the whole code, paste it and change it. 0, 1, 0, 1. I'm not looking at this side. Okay. You look at this side while I'm writing the code. Left, left should be 0, 0, 1, 0. And then let's comment the right side, and right side is 1, 0, 0, 0. And then stop, stop is 0, 0, 0, 0. Let's save the code, and the name is P4 this time. Robo Workshop P4 export, double tap, browse. P4 is here, P4 file is here. If it's not creating the hex file, that means you must having the error in the code. It's not compiling. Once you see the done compiling, after that only you can check the hex file here. So now if I go click play, I can see clockwise all the motors, anti-clockwise all the motors, right? 1 sec. I'll do what? I'll record this one for you and you check the output. Okay, give me a moment for this. Yes, now I'm doing it. Let's click play. Clockwise, backward, left side. Okay, right side, motors are not working. We need to check. Stop. Okay, we need to check. Although I'm sharing the not sharing video, otherwise it will create problem. So what's the problem? In the right side, it's not going. It was 1, 0. Let's come back. Let's come back to the circuit. Forward, it's working. Backward, it's working. Left side, it's working. But for right side, it's not working. Left side motors are not working for the left operation. We must have done anything wrong in the code. We need to check. So what we have done, 1010 is good. 0101 is also good. 0010 is good for left side. And for right side also we have done correctly 1000, but delay we have not used here. That's why it's not performing the right operation. This was the problem. So let's export again. And again, I'll click play. So clockwise is fine. Forward, backward, left is going good. Right is again not doing. Okay, now I need to Click play again. I'm recording now. Backward, left, right, and stop. And again come back to forward operation. Okay, it's done. Now I'm sharing the small recording of this. This is being done. So now four-wheel robot is absolutely completed. Okay, I'll save this design. Robo workshop. Where is this folder? Here it is. Design of P4. I didn't save other designs. I saved this one. Closing it. Right. Closing this as well. Closing this as well. Now tell me what questions, what doubts do you have? Let me read the chat also. You didn't understand the left right. See, whenever you have to go left side, stable your left side and move the right side. Okay. Whenever we have to go left side, stabilize the left part. It's simply you have to imagine when you have to go left side, obviously left side motor should not work. It should be stable and move the right side and the vice versa. That's what we have done here. Mr. Kamal, the logic of 0 1 is simply low and high. If you have to stop, write 0. If you have to move, write 1. So 1 0 is what? For that, I guess you have not joined the session from starting. That's why you not understood this. 1 0. If you write 1 mean 5 volt, 0 means 0 volt. How to rotate the left wheel anti-clockwise. Clockwise mean, see, 1 second. I need to re-explain the process. Now look at my screen. I'm picking motor. And a motor with logic toggle. Logic toggle is to understand 1 0. Okay. This is logic toggle. Logic toggle 1 and logic toggle 0. This is positive terminal. The upper one is the positive. The bottom one is the negative. Right? How we identify? Look at this. It will mention positive, negative here when I place the cursor. So if I place the cursor here, it is showing positive. When I place the cursor here, it is showing negative. So now if I give the logic 1 0, 1 0 mean what? 1 I am giving to positive terminal and 0 I am giving to negative terminal. So 1 mean I am giving 5 volt, right? At this point, I am giving 5 volts for now. And at this point, I am giving 0 volts. So what is the potential difference right now? It is 5 minus 0. That is equals to 5 volt. That is why the direction is clockwise. And now, when you give the logic 0 1, 0 1 is what? This is 0 1. So if you give the logic 0 1, that means you are giving how much? You are giving 0 volt at positive pin and 5 volts at negative pin. And this means the potential difference is 0 minus 5 equals to minus 5 volt. Correct? And if it is minus 5, the direction is anti-clockwise. This is the concept we have used to move your motor forward, backward. So if you have to go forward, it should be clockwise. And for backward, it should be anti-clockwise. Now, what was the operation of left right? Left right is also very simple. Whichever side you have to go, stop that side, stable that side. If you go left side, so move the right motors, stop the left motors. If you go right side, stop the right motors, move the left motors. Correct? This is the very simple concept. But if you want, if you have to go left side and both sides should be working, then the concept is a bit different. For left side, for left turn, move left motors anti-clockwise and right motors clockwise. This will take a sharp turn like this. which is called 360-degree rotation, which is also called a drift. And when you go right turn, move right motors anti-clockwise and left motors clockwise. So this is a sharp turn for right side. Correct? Now I'm coming back to the chat box. So we have used 2 times delay. Maybe that's why that was waiting for too long. Delay mean someone is asking delay. So delay is simply a time duration between the two conditions of output. So if I write 1000, it means 1 second. If I write 2000, it is 2 seconds. It is actually what we are writing in milliseconds. So 1000 equals to 1000 millisecond is equals to 1 second. Mr. Ronak, I have shared all the values of binary. See, these are the values. Forward 1010. As I just explained, for forward positive should be 1, negative should be 0. For backward, for backward mean anti-clockwise. For anti-clockwise, positive should be 0 and negative should be 1. And for left side, what I have done is I stop the left motors and move the right motors clockwise. And for right side, move the left motors clockwise and stop the right motors. So these are the binary values. Yes, Digambar, we can do simply, we have to write the logic. See, this is left turn, right? Let me write it here. This is left turn. When I'll say left turn, okay? Now, if you want another process of left, it can be 0, 1 and 1, 0. This is left sharp turn. Sharp turn when, see, here what you did. Left motor was stopped and right motor clockwise. But now what I did, left motor anti-clockwise and right motor clockwise for the sharp turn, 360-degree drift. And for right, you can do the same. For right, left motors clockwise and right motors anti-clockwise. So this is right sharp turn. Okay, now coming back to this, I'm using all the motors in operation. Ronak, can you please unmute yourself to ask your questions? You can even ask in your language, Hindi or English, I mean, both options you have. Please unmute because I didn't understand your last question, what you said. Do it quickly. Okay, you understood. That's fine. Okay, guys, so we are done for the day, right? And now we'll meet tomorrow at the same time with the same meeting link. Before that, I'll share the video of the session. Also, I'll try to share the codes and the circuits. But trust me, if you will open my circuit, it will open my code, it won't give you the exact learning. For that, I request each and everyone to create your own codes, write your own codes, create your own circuit, and then go to the next level with me tomorrow. And the agenda for the tomorrow is to understand wireless robot. Okay, and we give the command through any other device to move this robot in forward, backward, left, right directions. Also, we'll try to wind it up with the understanding of ROS, robot operating system, which I told you in the theory in the introduction part when we started this session. For now, that's it. Thank you so much, each and everyone, for being here. Let's see you tomorrow. And I hope you'll complete each and every process we have discussed. Right? Thank you so much. Bye bye.